I'm Jordan Hankin. Welcome to 7.2 Trigonometry Integrals Sine and Cosine. This is period 4 Calc BC. So, when you're doing trig integrals, you're going to want to remember these useful identities. Up here you have sine squared x plus cosine squared x equals 1. Here you have sine 2x equals 2 cosine x times sine x. Here you have cosine 2x equals cosine squared x minus sine squared x, also equals 2 cosine squared x minus 1, and also equals 1 minus 2 sine squared x. Next you have your power reducing formulas. Start off with sine squared x goes to 1/2 times 1 minus cosine 2x, and then cosine squared x goes to 1/2 times 1 plus cosine 2x. Also, I have your simple trig integrals. First you have sine x goes to negative cos x plus c, and you got cosine x goes to sine x plus c. Alright, so let's jump into some problems here. So let's start with this first one here. We got cosine cubed x dx. Remember, this is not like x cubed dx, which goes to x4 over 4 plus c, because this is a different sort of function. So what you're going to want to do for these sort of trig substitution integrals is you're going to want to separate the functions into things like this. So you got cosine squared x times cosine x. So if you look back at your useful identity sheet, you'll see that cosine squared x goes to 1 minus sine squared x. So you substitute that in, get this times cosine x dx, and you can see that this is a perfect time to do a u substitution. So you set u as sine x, du is cosine x dx. That gets you to 1 minus u squared du. And that's a simple integral where you end up with u minus u cubed over 3 plus c, and that turns into sine x minus sine x cubed over 3 plus c. So really the whole goal of a trig substitution is to get it to some place where you can do a u substitution through that trig substitution, where your separated function is used for the du. Alright, let's move on. So for 2, you have integral of sine cubed x times cosine squared x dx. So it's another one of the cases where you're going to want to separate the functions into sine x times sine squared x times cosine squared x dx. So since you have the singular sine x right here, you're going to want to move it into a function that can use du as sine x. So you can see that you're going to want to change sine squared x into 1 minus cosine squared x, simplifies into cosine squared x minus cosine to the fourth x times sine x dx. You set u to cosine x, du is negative sine x dx, which brings you to here where it's negative integral of u squared minus u to the fourth du. I just put the substituted the negative back in and got u to the fourth minus u squared du. That's an integral that turns into u to the fifth over 5 minus u cubed over 3 plus c, turns into cosine x to the fifth over 5 minus cosine cubed x over 3 plus c. Okay, now on to the next problems. So for 3, again, this is another one of those separation sort of problems where you get integral of sine to the fourth x times cosine x cubed dx. And so when you're doing these sort of problems, you're usually in this specific type of problem, you're going to want to find which function has the odd power. In this case, it's the cosine x, and that's the one you're going to want to separate out, which I did here. So I end up with cosine to the fourth x times cosine squared x times cosine x dx. You do another one of those substitutions where you end up with sine to the fourth x minus sine to the sixth x times cosine x dx. Turns into u. You do the u substitution, where sine x is u, du is cosine x dx. You get u to the fourth minus u to the sixth du. Gets you this simple integral where your final answer is sine to the fifth x minus over 5 minus sine to the 7x over 7 plus c. So number 4, you have this problem here where both functions are of the same order power. They're both squared, sine x squared and cosine x squared dx. So in this case, you're going to want to use a different type of identity. You're going to want to use the power reducing formulas. So for sine squared x, it becomes 1 minus cosine 2x over 2. That's 2x, not squared x. And then cosine squared x becomes 1 plus cosine 2x over 2 dx, of course. So my first course of action is to pull out the 1/2, which gets you 1/4. Then you multiply the tops here, which gets you 1 minus cosine squared 2x dx. And then, so you're at this point here, you're going to want to do another substitution / identity, where it becomes 1/4 integral of sine squared 2x dx. That's another one of those identities from that useful identities page. And again, you have one of these squared functions, so you're going to want to do another power reducing formula, which turns it into 1/4 integral of 1 minus cosine 4x over 2 dx. You make it 4x because there's already a 2x inside of the function. So that becomes 1/8 integral of 1 dx minus 1/8 cosine 1/8 integral cosine 4x dx. I just split up these top two values into the integral, and that gets you this easy answer of x over 8 minus sine 4x over 32 plus c. So let's do a problem with definite integrals. So our problem starts out as you have the integral of 0 to pi sine of 3t to the fourth. So you have a function within the function. So first thing that I would do is change it into this, sine squared of 3t all squared. This allows you to do the power reducing formula here. So that gets you 1/2 times 1 minus cosine 6t all squared. Then you can pull out the 1/2 squared, gets you the 1/4. Then you multiply through that squared polynomial now. So you get 1 minus 2 cosine 6t plus cosine squared of 6t dt. You carry that through into this, where you have this squared still. So you're going to want to do another power reducing formula, which gets you 1/4 integral of from pi to 0 of 1 minus 2 cosine 6t plus 1/2 of 1 plus cosine 12t all dt. So let's combine some like terms here. Gets you 1/4 integral pi to 0, 3/2 minus 2 cosine 6t plus 1/2 cosine 12t dt. So from here you can just carry through the integral, where you get 1/4 of 3/2 t minus sine 6t over 3 plus sine 12t over 24, all from pi to 0. So you carry through all these values, you get 1/4 times all these values, which turns out the only one that isn't 0 is 3 pi over 2. So you multiply 1/4 through that, and you end up with 3 pi over 8. So that's how you're going to do these trig substitution integrals. I'll show you how to do some sort of integral on your calculator like that. So let's say you want to do the integral of that first problem, cosine x cubed, from 0 to pi over 3. So what you're going to want to do is type it in to your calculator like this. If you have an 89, you type it in like that, you set the limits, you set the x, it'll spit out this answer. Of course, if your calculator isn't allowing you to get the exact answer for some reason, what you can do is find the integral manually and then set it up something like this, where you have the integral and then set the x value to pi over 3, which gives you 3 times root 3 over 8, and then do the same thing where it's set to 0. In this case, it's 0, so it doesn't matter, but if the two values were non-zero, you'd subtract them, and you'd get your final answer, which in this case would be 3 times root 3 over 8. So that's really how you do trig substitution integrals for sine and cosine, and there will be some problems on the worksheet for you to do to learn more. Thank you.